Okay, now we are looking at solving trigonometry question, but in this case is slightly more complex than the one you have learned earlier, whereby you have only one trigonometry equal to some constant and you work it out. Okay, but here you could end up a quadratic equation of trigonometry. Okay, to solve this type of question, normally you have to use the identity here. Okay, now let's look at question number 3 first. Okay, question number 3 say that 8 sine 3 cosine 2 theta. Okay, now how would you able to find either sine theta or cosine theta? Okay, the way of solving this is this. The rule is this. If you look at sine theta and cosine square theta, you see the sine theta is have power of 1. Okay, so the rule is you always convert the trigo which have power of 2 to similar with the trigo with a power of 1. In this case, sine theta. That means I have to convert the cosine square theta to sine theta. So what you do? See, so we want to convert the cosine square theta to some expression whereby you have a sine theta. Okay, we always follow this. So if you look carefully, cosine sine theta, if you make cosine square theta as a subject, then is equal to 1. The sine square theta actually move to the right hand side. So if cosine square theta is actually equal to 1 minus sine square theta. So from here, 8 sine theta is actually 3. And we're going to substitute the cosine square theta by 1 minus sine theta. 1 minus sine square theta. Okay, now let's expand this. You got 3, you got minus 3 sine square theta. Okay, now let's move this to the left hand side. So you got 3 sine square theta plus 8 sine theta minus 3 equal to 0. Okay, if you let x equal to sine theta, you actually have a quadratic equation. So it's actually 3x squared plus 8x squared minus 3 equal to 0. Okay, so sine theta is x, so 8x. 3 sine square theta is actually 3x squared. So this actually is a quadratic equation. Okay, but actually you do not need to provide this statement. You can straight away go and factorize. That means I can write 3 sine theta sine theta minus so it's minus 1 plus 3. Okay, so if you expand this, you get 3 sine square theta plus 8 sine theta minus 3. Okay, now so this is equal to 0. Therefore, you have 3 sine theta minus 1 equal to 0, or sine theta plus 3 equal to 0. Rearrange this one, you get sine theta equal to 1 over 3. And then you also have the case where sine theta, like this case, you bring the plus 3, become minus 3. Okay, so from here you continue do the working, the usual working, to find the theta value. Okay, that's it. This part here, you must know how to manipulate. Okay, now let's look at question number 9. Here, question number 9, 2 cotangent theta plus 11 equal to 9 cosecant theta. Okay, now remember I say you always convert the square term, the term with the square term, to cosecant. Okay, now let's go and look at this. Okay, cotangent square theta. If I bring the minus 1 here, cos square theta is equal to cosecant theta square minus 1. Okay, so in other words, this question number 9, can be written as 2 cosecant theta square minus 1 plus 11 cosecant theta. So let's simplify it. So 2 cosecant theta square minus 2 plus 11. This bring over become minus 9 cosecant theta equal to 0. Simplified further, 2 cosecant square theta equal to minus 9 cosecant theta minus 2 plus 11 give you a plus 9. Okay, now cosecant square theta, if you let cosecant square theta as, cosecant theta as x, so this is basically 2x squared minus 9x plus 9. Okay, now so what we're going to do is we're going to factorize this, assuming cosecant theta as x. Okay, so it's 2 cosecant theta minus 3 cosecant theta minus 3. Okay, you get a minus 9 this. Okay, now so therefore 2 cosecant theta minus 3 is equal to 0, or secant theta minus 3 minus 0. So simplifying, you got cosecant theta, 3 bring over become 3, this 2 in front here become 2. Okay, then this one will be cosecant theta equal to 3. Now remember, finally you have to convert this into either sine, cosine, tangent. So 1 cosine secant is actually 1 over sine theta equal to 3 over 2. Okay, then this one also 1 over sine theta to 3. So make sine theta the subject, 2 over 3, and sine theta become 1 over 3. Okay, so now from here you convert using the normal method to find the theta value. Okay, so this is the part that you have not done before. Before you learn the identity. Now you have learned identity, you can solve this kind of question. Okay, so this part here is using the identity to simplify it. From here onward, you use the normal method to find the theta for both. Okay, now let's look at this. How will you solve this? Okay, let's look at 12. Question 12. How are we going to simplify this? 3 cotangent theta. 2 theta plus 2 sine 2 theta equal to 0. Now, in this case, it's slightly different. You don't have a term whereby you have a square. You see, this one is 1 cotangent to the power of 1 2 theta is 1. This is different from this case where you have one term to the power of 1, the other one to the power of 2. So we know this one have to be converted to follow cosecant. Similarly, for this sine theta have power of 1, this cosine theta have power of 2. So I'm going to convert the one with the power of 2 so that it will be having the same trigonometric term as the one with the power of 1, like this case. Now, what about this? There is no a term where you have a square. Okay. Now, for this case, you have to do it slightly different. You got 3. Let's convert this. This actually become cosine theta over sine theta. Okay. Then plus 2. Oh, sorry. There's this is actually 3 cosine 2 theta over sine 2 theta plus 2 sine 2 theta is 0. Okay. Let's draw a line here. Okay. Now, let's multiply sine 2 theta across. So the sine 2 theta will cancel off. So this is left with cosine 2 theta. This will end up with sine square theta. Square 2 theta. Okay. Then sine 2 theta times 0 will still give us 0. Now, we end up the same situation now. You have a power of 1 here. You have a power of 2. So what we have to do is to convert these to the same trigonometry term as the one with the power of 1. So this one actually equal to sine 2 theta square. You look at this trigonometry, so it's actually 1, you bring the cosine over, so it becomes 1 minus cosine 2 square 2 theta equal to 0, 3 cosine 2 theta. Okay, now let's simplify this. So you got a minus 2 cosine 2 theta, basically 2 times this, and then plus 3 cosine 2 theta plus 2 equal to 0. Now, we do not want a square term with a negative. Multiply by minus 1 across. So So you end up with 2 cosine 2 theta minus 3, because you are minus, this one minus become positive, but minus times positive become negative. Okay, so it become 3 cosine 2 theta. This become minus 2. Minus 1 times 2 become minus 2. Okay, now you have a quadratic equation now. Then you have to okay, so you have to factorize 2 cosine 2 theta, and then you got cosine 2 theta. Okay, now so you got minus 2 plus 1. Okay, so you factorize. Therefore, cosine 2 cosine 2 theta plus 1 is equal to 0, or cosine 2 theta minus 2 equal to 0. So making cosine 2 theta the subject is equal to minus 1 over 2. And then you have to work on also cosine 2 theta is equal to 2. Now, cosine of any angle, as I said before, cosine of any angle, okay, is from minus 1 cosine of any angle. 2 theta is also angle. It can only exist within this range, but now you have got a 2. Okay, that means to say here there's no valid answer. Okay, so this one you proceed and work on using whatever you have learned to find the theta value. Okay, hopefully this will help you to understand how to solve this type of even more complicated trigonometry question.